today's video we'll be looking at the exponential equation part 2. We'll be looking at some examples. Okay, so let's look at example number 1. Well, if we have 3 times 2 raised to the power 2x minus 1 into bracket minus 2 raised to the power 2x plus 1, right, all divided by 4 raised to the power x, which is equal to 2 minus 2x and then minus 1. Go ahead and solve this expression here, or rather this equation. Solve for x, right? So you can feel free to pause the video and try this by your own, right, by yourself. Okay, so the first thing that you have to do, well, you can cross multiply, divide this by 1, and then you can cross multiply in that case. Okay, let us cross multiply. We will have 3 2x minus 1 and then minus 2x plus 1, which should be equal to, well, this is 2x, right? This can be 2x. Remember, 2 squared is the same as 4, and then that x there, which gives us 2x, right? Remember that. Remember, whenever you're dealing with the exponents, you always want to change these into prime factors, other factors of prime numbers, right? So this one will be 2 negative 2x and then minus 1. Okay, so if you can distribute this inside, you will have well, this will be 2, that will be 0 there, right? Yeah, that will be 0, because if you times the same basis, you add the exponent, that will be 2 raised to the power 0 and then minus 2x, right? So here you can see we have 2x minus 1, then minus 2x plus 1 is equal to 1 minus 2x. I hope that makes sense. Okay, so now what I'm going to do is I can see that, okay, on the left hand side I have these 2 common things here, which is also common with the this one here. So meaning I want to transpose this to the left hand side. So I'm going to have 3 and then 2x minus 1 minus 2x plus 1, and then transposing that, it will be a positive 2x, which is the same as 1 in that case, which is equal to 1. Okay, okay, got it. Okay, so moving on to the next step. So here I can take out the common factor, 2 raised to the power 2x, therefore 2x, which is the same as 3 times 2 negative 1 minus 1 plus 1, which is equal to 1, right? I hope that makes sense. Hope this makes sense here. And then here I can divide, or rather I can put this on my calculator. So if you plug this on a calculator, you should get 3 times 2 negative 1 minus 2 plus 1. You should get 3 over 2, right? Which is equal to 1 in that case. Oh no, not 3 over 2. 1 over 2, yeah. You should get 1 over 2. 1 over 2, which is equal to 1. And then if I divide everything by a half, if I divide everything by a half, this side here, these two will move, and hence on the right hand side I'll have 2. Therefore 2x is equal to 1, and hence x is equal to a half. Yep, so x is equal to half. If you got this, then hey, congratulations. You can now do more examples, because this one was a complex one. It's more challenging. So yeah, so let's look at another example. Okay, let's look at another example. Please feel free to pause the video and try these on your own. Right, let's look at another example. Right, let's look at another example. Let's say 2. Let's make this easy. Let's say 2x squared divided by 4 raised to the power x, which is equal to 8. Feel free to pause the video and try this on your own. So here we have 2x squared. Remember, whenever you're dealing with exponent, you always want to change the bases. Always want to change the bases into prime factors, right? Into prime numbers rather. So a prime number here will be 2x. You can change this in a calculator, and then here you have 2 raised to the power 3. Right? We have the same bases, and hence we're subtracting the exponents, and therefore 2x squared minus 2x, which is equal to what? 2 cubed. Right? The same exponents drop, the same bases drop. Yeah, the same bases, you drop them, and then you equate the 2 exponents. So therefore I got 2x, which is equal to 3, and therefore x squared minus 2x minus 3 is equal to 0. And then you can just solve this. Using the quadratic formula, or you can factorize, right? So that will mean x is equal to 3, or x should be equal to -1. I hope that makes sense. Okay, let us look at some more examples here. Okay, let us say we have 3 raised to the power 2 minus x, which is equal to 3 raised to the power x minus 8. Okay, feel free to pause the video and try this on your own. Okay, so here we'll have 2 minus x. I'm going to transpose this one to the left, right? I'm going to transpose this one to the left. If I have negative 3x, which is the same as negative 8. Well, in this case here, we notice that we have a negative, right? We have a negative, well, you have a negative, what do you call this? You have a negative exponent, right? But here we have a positive exponent. So what do we do in this case? Well, let us see. So if I break these two, well, I have 2, right, times 3, 1 over x. Remember, when you have that, or rather, let me just do it step by step. Therefore I have negative x, then minus 3x, which is equal to negative 8 in that case. Okay, so here I'll have 3 squared, and then times this one becomes 1 over what? 1 over 3x, right? 1 over 3x minus 3x, which is equal to negative 8. I hope that makes sense. And therefore I'm gonna times everything by this 3x here. So I will have 2. When I times this one, it will remove. Therefore I'll have negative 3x times 3x, which is equal to negative 8 times sorry about that. Yeah, okay, 3x. Okay, so moving on, here you can see that we will have a quadratic equation minus 2x, which is equal to 8 times 3x, right? Therefore I'll have 2x. I'll transpose everything to the right. Here I'll have 0, minus 8 times 3x, and then minus 3 squared. Okay, so simplifying or vectorizing this will lead us to, you can let 3x be equal to k if you wish. Therefore you have k squared minus 8k, and then minus 9, of course, right? Minus 9, yes. So therefore I'll have 3x, and then you can factorize this one here, right? So therefore I'll have 3x, then I'll have 3x here. Therefore here I have 9 and 1. Then here there's a negative, so therefore negative and positive. Therefore 3x should be equal to 3 squared, because 9 is 3 squared, or 3x should be equal to negative 1. So what does that mean? It means that, well, x in that case is equal to 2, because you're dropping the bases. And then here, now when it comes to this one here, there's nothing you can do with this one. Therefore there is no solution, right? There's no solution. So you cannot say, well, this is the same as, there's nothing you can do about it, right? You can't say it's negative 3 raised to the power 0, right? Negative 3 raised to the power 0, well, that will give you a negative, it is the same, but when you say 3x is equal to negative 3 raised to the power 0, now the bases now are not the same, right? The bases are not the same, right? And another thing is, there is no x value that you plug in there in place of x will give you a negative number, right? So even if I have 3x equal to negative 1, there is no x value, positive, negative, rational, irrational, whatever number that you plug in place of x that you put there, it will not give you a negative, right? It will never give you a negative number, right? Even if you put negative 1,000,000, it can never give you a negative number, right? So meaning there is no solution for this part here, right? I hope this makes sense. And yeah, this part here is very easy if you know your rules, if you know the rules, and you watched the other video that I did prior, right? You will understand this. And yeah, this is simple as that, right? So that's it for this video. I'll catch you on another one. We will be looking at the graphs, and we'll be looking at the logarithmic graphs, as well as the natural log, the natural log graph, right? Which is the ln, the ln function and the log function, right? I hope this makes sense here. I wanna stop here, and I'll catch you on another one.